Students, now we have come to the unit 2 part of the protected cultivation, and this is about the irrigation and water management. So this is very important that inside the protected structures, as we are not allowing the irrigation by flooding, and we are not allowing the rainwater to come inside. So it is very important that we should irrigate these crops with the proper water. And normally drip irrigation system, which is called the micro irrigation system, it is used to irrigate these greenhouses. So here in this presentation we will be discussing about what is the drip irrigation and then the different components of drip irrigation system, something about the maintenance part also, and the equipments in by with the help of which we are also using the drip irrigation water for fertigation. I mean, the fertilizer is mixed with the irrigation water and it is applied. And then something about the foggers and misting systems, which is very essential in these structures. Before going for the discussion on drip irrigation, it is good if we just have a general round on the irrigation, that is the artificial application of water on the. So any way by in which if we apply the water by artificial means, that is it's not the rain but it's the maybe canal, ponds, or maybe by the flooding. So this all comes under irrigation. So then the idea behind irrigation is to have water supply in the root zone, so that there should be enough moisture for the plants to grow. Then accordingly, as per the requirement of the plants, and then naturally for the proper plant requirement and for preparation of the fields, we normally go for irrigation. So, students, as in order to have proper water requirements in case of drip irrigation, as we are using water in a very precise manner, and only in the calculated amount is given to the system at regular intervals. So there are different factors on the basis of which these water requirements are calculated. So, and these water requirements are called as PWP, that is the peak water requirements. And this is normally the requirement of a plant like being calculated, like the system is designed in such a way that on a hottest day and at the highest temperature in the day, how much water is required by the plant. So as in order to meet that kind of water requirement, the system is designed. The different factors on the basis of which uh, this has been designed. It is pan evaporation factor, pan factor, or crop factor, canopy factor, and the area occupied by the plants, this is also taken up. There are the 2 3 factors which are normally available in the form of a particular area in which you are working in. Now, this is something very interesting to note in this picture that will help you to understand the concept of irrigation. What happens when we irrigate a plot. So when we irrigate a plot, what happens once the soil which is dry, it start absorbing water, and whatever the pores are there, which are filled with air earlier, which is in the structure of the soil, they start getting filled up with water, and air start getting out from there. It gets expelling from there, and a situation will come when all the pores which are present in soil get filled up with water, and this situation is considered as the saturation capacity, and in which the water is 100%, or you can say the soil is 100% saturated, and all micro and macro pits pores are filled with water. This is a situation which is not stay for a longer period, and the water start moving from the soil, whether going infiltrating, going downward under gravity, and also there is a runoff. So there is a runoff also starts from there, like this is a gravity, and then there's a movement in the sides. And what happens gradually, the water from these macro pores initially get removed. So, if we think on irrigation point of view, then it is something like a futile exercise. You can say that once you are putting a water there, and then getting filling the water in the land, and then you are waiting that the water recedes from there, and then a situation will come when your macro pores get emptied, and the water remains in the micropods. And this is the, you can say, the ideal situation, or you can say the best situation as far as the agriculture is concerned, which is called the field capacity situation. Now in this situation there is moisture also, air also in the soil, and this is the best time to plant and grow the crops. Now, an ideal condition is like in which this kind of system remains for a longer period or forever. Now, what happens in general irrigation? As the water start receding and there is a evapotranspiration losses also, gradually the water level goes down, and a situation will come when the water from micropores also get removed. Now, a situation is this, which is called the permanent wilting point, or PWP. Now, the water beyond that is not available to the crops and to the plant's root, and hence the water present after that is coerced with quite strong forces, and it is not available. So, as an agriculture engineer or an agricultural agronomist, it is we have to think on the technology in which we can have this field capacity situation throughout. So that is the theory behind the drip irrigation, and with the help of this drip irrigation technology, it is possible that we maintain that kind of water in the soil, so that your soil remains under the field capacity throughout the growing season. Now, this is, we can say, is the application of small amount of water near the root zones uh, of the plants at frequent intervals through drippers. Applies water slowly, almost matching with the consumption water use of the plants, and to keep the soil moisture within the desired available range for the growth. That is called the field capacity. That is the field capacity, called FC. Now, water is discharged drop by drop at very low rate for a few liters per hour. Now, that is called the discharge rates of drippers, that is measured as LPH, that is liters per hour. And this system minimizes the water losses in the conventional irrigation methods such as deep percolation, runoff, and evaporation. So, this is, at one time we are coming up to the technologies which is normally now these are called as the GAPs, which is called the good agriculture practices, and this is, something happening like we are not allowing the water to be wasted, because water is considered to be a very precious input now, and it is not so freely available that we can use it indiscriminately. Secondly, if we pump out water regularly, and so it is happening that the water tables are going, or the groundwater tables are going down. So in order to yeah, save the situation, and to take the alarming in situation for this, we are more and more the government is emphasizing, and even the technologists and the scientists are also working on the judicious use of water, and it is through this technology of irrigation. Now, the benefits of drip irrigation is the high water use efficiency, that is, the production per unit consumption of water, and it is as good as 70 to 90% because you are only using water as per the requirement. Then the water and fertilizers can be applied uniformly to each plant. Now the fertigation plays a very hand in hand role with the irrigation, and so this is something like this. Now maintains proper soil air water relationships, so there is always a field capacity, so there is no issue. And when you are dealing with small amount of water, you are dealing with small land areas like the polyhouses and all, so you can treat the water if it is of some problem, or soil if it is with some problem, and naturally you can have a better control on the inputs. There is less evapotranspirational losses. Cultural practices are also reduced, and less and less energy consumption or electricity consumption is there in case when you are using drip irrigations. So these are few pictures you can just see here. This is the wet zone, and rest area is dry. So this is called the wet area zone, and it is with the orchard plants in which we are using these loop systems. And below here it is a picture from a greenhouse where there is a drip line and the plants are grown successfully. And secondly, the effective root depth of a plant is also linked with the water, and in the different type of soils, whether clay, loam, and sand, depending on the root zone and the perform the water, how it behaves in the soil, we are planning the irrigation timing. Now, in this picture, this is a very typical, you can say, drip irrigation system in which there is, you can say, the different components of a drip irrigation. Normally, the water which is being pumped out, or which is whether from a different sources, which can be any well, or it can be some canal, pond, or maybe some any other source of water, maybe harvested water harvested from roofs. This is first cleaned, so this you have to clean the water, and it has to undergo from certain filters. So then requirement of filters is based on the water and how the water is there, and accordingly you have this you can say the once the filters are installed and the clean water is there, and then the next is the network of piping. And from these network of piping, which is consist of main lines, sub main lines, and laterals, the water is made available till the last plant on the on the field. Then there are different components of a drip system. That is, if we just consider a drip irrigation system, then these are certain parts which are required, and the broader categories. The main components are filters, the main lines, sub main lines, laterals, and drippers. And the other components which are also fitted in the in a drip irrigation system is a bypass assembly, NRV, which is called the non-returning valve, fertigation tank, pressure gauge, control valves, air release valves, and flush valves. Now they have different roles, which we will be taking up, when we will be discussing about the different components of a drip irrigation system. So this is about the something about the drip irrigation. Thank you, students.